You are looking at thermal imaging of a 445 watt solar panel in a fixed position on my solar electric lithium iron phosphate battery microgrid. And below it is a test bench where I put trays of materials and I meter and record various tests, including for what we call circular solar, that's in the patent filing stage. Thermography is a really wonderful technology where you're able to pinpoint and have a visual map of cold and hot, wet or dry matter that we can't see. And it's beneficial for planning sustainable energy projects, infrastructure, architecture. I feel it's a great tool for essentially accurately planning and designing for climate change. So we're able to take images of real-time images and simultaneously do the thermal imaging. Here's my laptop, and to the left you can see the LFP battery bank, and then to the right is the other Bluetooth software where I'm able to track where every watt comes and goes down to the second. So in a nutshell, essentially this has all been designed around the ability of being able to test various materials under two different types of solar panels and how they contribute to output, and therefore charging and discharging of storage or propulsion batteries, and of course also their behavior while under low and high electric loads. So these are the materials below that solar panel, which is a 445 watt utility scale panel. This is an example of the testing I do. So we have 3 different materials here that are part of the equation of what that solar panel, what its output will be. Right now I have a 1,000 watt toaster oven being ran, and so it's pulling via inverter off of these materials are affecting how much solar is being produced and therefore powering the toaster oven and discharging from the battery, which is well, it was pulling at about 25 amps each. Right now we're generating about 205 watts of solar. This is the sun's direction. It's far off to the side. It's March 2nd, so it's also pretty low. And then here's the underside of the panel. Panels are rated at 77 Fahrenheit STC rating, so it's a bit cool today. And then these materials are part of that equation. I'll show you these birds flying. Let's see if we... Pretty cool. Anyway, it's 4:30 and I'm just doing an updated thermography test. Hang on. Let's see if we can see the birds. I don't think so. Anyway, you can hear them. So it's about 4:30. The solar panel power's dropped down to about 103. This is all in the shade on the far left. And then you can make out these areas that are sunny. And then here is the underside of the panel. I'm thinking the outside air temperature is probably about 54 by now. And then let's see it's definitely gotten colder. The voltage is up 43, and when it was a little warmer and the output was in the 200s, it was about 40 to 41. Okay, and that's the test.